Assalamualaikum warahmatullahi wabarakatuh to Encik Saiful Firdaus and Dr. Muhammad Suhaimi. Today we are going to present to you our Capstone project integrated system design. Our supervisor is Puan Azwati Azmin. The title of our project is IoT Enable Real-Time Student Health Monitoring from Unit Kesihatan UITM to Hospital Emergency Department. This idea was sparked by a personal experience that I had with a friend of mine not long ago. During co-curriculum activities on semester 3, my friend fainted and was transferred to the emergency department via UK ambulance. Upon arrival, they had to manually register at the emergency department, which took quite a bit of time. We were left waiting for the evening until late at night. The entire process was slow and the response and also the treatment were delayed due to high congestion and hectic situation at the emergency department. This is where our idea of project comes in. IoT Enable Student Monitoring aims to address these issues by using IoT technology to track students' health data in real time. This system will allow medical staff to receive immediate access to vital signs without the need for manual registration, reducing wait times and also improving treatment efficiency in emergency situations. Our main purpose also is to prioritize the students' health, especially in critical conditions. Now, we are going to introduce ourselves. My name is Nur Amir Husna binti Muhammad Fuad with my other members Nur Azwaliza bin Azmi, Abdul Hadi Shafi'i bin Yusri, and Muhammad Adli Takif bin Zulkifli. Next is site visit and user requirement. This is during our interview session with Puan Husin Banu Zakaruddin, who is the staff nurse at Unit Kesihatan UITM Cawangan, Pulau Pinang. Unit Kesihatan UITM, which serves as the primary health unit for students, especially UITM students.
Now, I will explain the introduction of our project. So, the IoT Enable Real-Time Student Health Monitoring System is a connection between UITM's Unit Kesihatan, which is health unit, with the hospital emergency department. This will allowing continuous tracking of a student's vital signs like heart rate, blood pressure, and oxygen levels from the moment the ambulance arrives until they reach to the hospital. This IoT device in ambulance will send this health data instantly to the hospital so that giving the doctor a real-time updates on the student's condition before they arrive at the hospital. This system will help the hospital prepare the right resources and care in advance, and also reducing delays and improving the chance of effective treatment. And this design is to make emergency care faster, more accurate, and better prepared to handle urgent health situations for students.
Let's moving on to problem statement. From the previous experience that we have faced, here we want to highlight the key issues that lead to the idea of this project. With more students needing fast health care, the real-time student health monitoring project connects the ITM's health unit to hospitals. This system watches student health in real time, quickly finds urgent cases, and makes sure serious issues get help right away. First problem is the lack of continuous real-time monitoring of student health metrics limits the ability to detect and prioritize health emergency in a timely manner. The second problem is the absence of efficient communication and data exchange between Unit Kesihatan UITM and the hospital emergency department that hinders the quick assessment and handling of critical student health situation. The third problem that we want to highlight is the congestions and pressure in the emergency department lead to students' health concerns not receiving the priority and attention they require.
So in order to make our project streamlined and possible, there are a few objectives that must be completed. The first one is to design and develop a real-time monitoring system to continuously track student health metrics for timely detection and prioritization of emergencies. The second one, to enable seamless communication and data sharing between the unit kesihatan UiTM and the emergency department hospital for rapid prioritization and response to serious health incidents. And finally, after both of them is been completed, to evaluate the effectiveness of the monitoring system and communication system in improving the emergency response times and prioritization of accuracy in healthcare setting.
Next, about project description. So first, manual health check at unit kesihatan. So doctors or nurse will check the student's condition as usual by measuring vital signs like heart rate, blood pressure and temperature. Next is about emergency alert button. When the condition of the student is critical or abnormal, the healthcare provider will press a push button to immediately alert the emergency department at the hospital. So, at the hospital, this will trigger an LED light in the emergency department, which is signaling that a serious case is incoming. Next, about continuous data transfer in the ambulance. So, health monitoring device like heart rate monitor, blood pressure sensor will be used to collect the student's health data during the ambulance ride. So this data will be sent continuously to the emergency department via an IoT-based communication system in the ambulance. Lastly is about preparedness in the emergency department. So, the emergency department will receive real-time updates on the student health, and this is also will allows the medical team to be ready and prepared for immediate treatment when the student arrives at the hospital.
So now about progress scope and implementation. Our study area is at UiTM Pulau Pinang because unit kesihatan is primary health unit for the student and we target hospital and the department. Next about target audience. Our main focus at student of UiTM Pulau Pinang. And parties involved is medical staff at unit kesihatan UiTM and emergency department hospital. Next about main case criteria. So first is about the critical zone. So this system we focus on cases that fall into yellow and red zones. Prioritizing condition that may require immediate or urgent intervention. Next about the data and trends. So the key health parameters to be monitored include the heart of pulse rate, blood pressure and oxygen saturation with the ability to trigger alerts if the values reach threshold that signify an emergency case. Next about specific aspects. This is about IoT integration. We develop an IoT system which can gather real-time data via wearable device or sensors used by unit kesihatan UiTM. So this data will be processed and sent from unit kesihatan to the hospital emergency system. So according to our project, the outcome is the faster emergency response time for students experiencing health cases like me. For this, next about enhanced communication and data sharing between unit kesihatan and emergency department. Lastly, we will reduce risk of escalation for serious health conditions. Next, in this section, we will cover the data collection, like how and what type of data that we want to collect and how we collect the data. Second, sensors and components used to execute this project. And third, several level to show how this project flow. How the monitoring system flow. Fifth, software that we use to do coding and simulate, and the last one, the IoT platform that we want to interface integrate with the monitoring. So the first one, data collection. What are the vital signs that we want to measure? These are the primary is heart rate, blood pressure, oxygen saturation, and glucose condition. Okay, so this is the range of age by the signs for adults students. We assume that all the students here are already adults. So the first one is heart or pulse rate. We measure the pulse or heart beats in beats per minute, like how many beats in 1 minute, at fingertip, wave or wrist for more accurate data. So it actually detects the changes in blood flow or electric signal associated with each heartbeat. The normal range for beats per minute is 60 to 100. The next is blood pressure. We measure by exerted pressure and measuring the pressure exerted by circulating blood on the walls artery at arm above elbow for more accurate data collection. The normal range for adult is 110 until 120 for systolic and 60 to 80 for diastolic in millimeter mercury. Next is oxygen saturation. We analyze how light is absorbed by oxygenated versus deoxygenated hemoglobin at fingertip. The normal range is 95% to 100%. The last one is glucose condition. This is actually the first vital sign that medical staff will check. They will check manually using torchlight and see the size of the glucose condition. Is it 2 to 3 mm size? And it must be in round shape. If not, it means that the patient has severe head injuries.
Moving on, I will describe about the sensors and components used in our project. Firstly, we have 4 types of sensors used in order to make our project successful. First one is heart rate monitor, blood pressure, oxygen saturation, and also the pupil dilation. This is the first of the components, which is MAX 30102 as oxygen saturation sensors. It works by emitting light into the fingertip, and if oxygenated blood is present, the light reflected between its diode will be different from the deoxygenated blood. So if oxygenated blood has been through with the light emitted, it will turn blue. But if not deoxygenated blood, it will not turn blue. This is the first option. We have a different option in order to integrate into this project. The second option is a Bluetooth oximeter. If we use the first option, this is we from the ground up. We design the system from the ground up. We only buy the chip of the sensors. But if the second option, it is already on the market. So the display will already be there. We only need to incorporate the data from this equipment into our LCD output. But if you use the first option, we must include all of each sensor and also the connection between our microcontroller and the sensor. So the differences between these, apart from the description I said earlier, is the price. The price for option 1 is a little bit lower. It is cheaper, and the second one is little bit higher because it is a complete product. Next, this is for blood pressure sensor. We use the cuff. First option is already the complete set of cuff with Bluetooth blood pressure monitor. This is used to send blood pressure data accurately in millimeter mercury to the microcontroller. But the second option is also available. We use the cuff also, but we design the motor and also the valve to supply the air pressure, and from the cuff we don't connect to the, if you can see there's a monitor like that, but we don't connect to the monitor, but we connect into a pressure sensor that will be integrated into our motherboard. Next, this is the membrane keypad. This is our primary input selector. If there's option needed to be taken, such as the pupil is not dilated, the pupil is abnormal, you must input the key by using this component. And for the pupil assessment, we use the torchlight manually. This is the push button In order to start up our equipment, we must firstly push this button. Since the student arrived at the UK, the nurses will evaluate the condition of student. If the student is kind of just have a fever and not a very serious one, they will not activate the system because it is not necessary. The student will only given medication and sent back to their room. But if it very critical and severe, the nurse will push this button on the behalf of doctor, and the IoT system will turn on and continuously send data based on our description earlier. So for our microcontroller, we have decided to use ESP32 because it has integrated Wi-Fi and Bluetooth capability, and also a whole range of reasons such as it's cheaper, more available, and also we have some experience in using the ESP32 microcontroller. And finally, there is an LED and also the LCD display for our output. The LCD will determine the LED will indicate what type of severity the student is having, such as the red zone or also the yellow zone. Differences between these two are severity and also the site of the injury. The head and your chest is obviously very critical, so it will be in the red category. So it is most prioritized. If you have broken bones and all of that, it will be relegated to the yellow zone. So it is less severe, but also need to be taken attentively. And finally, the LCD display. The LCD display will display the data such as the oxygen saturation percentage, the pressure of your blood, and also all of our sensors output.
Next, for block diagram, as earlier mentioned, our code will using ESP32 for our main microcontroller. So, connected with that ESP32, we have 4 input, which are web, push button, blood pressure monitoring, and oximeter monitoring. So, from those 4 input connected to the ESP32, then we plugged in IoT cloud. Then from ESP32, we have 2 output, which are LCD and LED. So next slide. For the next slide is monitoring clock system clock flow. Let's say they are student.
This is the description of our system. It is quite good because it's hand-drawn by me. So actually, this is what we're planning to do about our product.
Let's say they are student teacher. The UK will place the student in ambulance, and the medical assistant will put the oxygen saturation and phosphate sensor at one arm, let's say right arm, and handcuff for blood pressure for another arm, let's say left arm. Then we connected to the LCD monitor equipment with sensor and microcontroller. Then after that, the medical assistant will check the equipment of the student. Then she or he will key in the data using the feedback.
So this is the software that we will use. Arduino IDE is we all have the experience using this software. So the application that is for IDE, combining and also application to interface with ESP and then also can integrate with other platform. So this is one type of IDE platform that I have an experience using it last semester. This is AWS cloud service that provided by Amazon Web Service. It uses protocols like MQTT workers to send the data from ESP32 into AWS IoT Core. And also, AWS also provides a service that can store the data after it is Free trial.
Ijaya.
Bagi sempat.
So next is the flow of project. Okay, first, let's say if there's an emergency from a student and they come to UK, so the staff will check the vital signs manually, and then if in medical field they actually have scoring how they want to classify different red zone. So if the abnormal case based on medical scoring is if the case is abnormal, the UK will transfer the student into ambulance and then will be connected, direct connected to the monitoring device. If not, they will get only normal treatment at this time. Okay, next, after the student has equipped with the monitoring device, the medical assistant in the ambulance will activate the push button to alert the emergency department. So at emergency department there will be LED and they will on to alert them that we have emergency case from the ATM. And also the vital signs will continuously monitor and send to the Azwati and send to the emergency department. That is the overall flow for our project. Okay, next. So this is the flow for monitoring vital signs. First, the monitoring vital signs will continuously measure the vital signs of the students. There are 1, 2, 3, 4 vital signs that we want to measure at the same time. First one is analyzing previous condition, that is manually by the medical assistant in the ambulance. And next one is measuring blood pressure, measuring pulse rate, and measuring oxygen saturation. All the vital signs will be measured at the same time. So let's go first with the previous condition. Okay. First, let's say if the size of the pupils is not equal to the 2 mm to 3 mm, or the shape is not round, so the medical assistant will manually key in the input using the keypad and send the data continuously to the emergency department through the platform. And the display, it also has as a display on the device that the prototype that we want to develop on, and display normal pupils. If abnormal, it will display abnormal pupils. Okay, next for measuring blood pressure. Okay, there are 3 conditions of blood pressure that we want to monitor. First one. Okay. First condition, if blood pressure, this is normal blood pressure, 110 under 120 for systolic and diastolic 60 to 80. If the range is normal, it will display as normal blood pressure. But if it less than the normal range, it will display low blood pressure. And the last condition is if it is higher than the normal range, it will display high blood pressure. And then the third vital sign is pulse rate. We are sending the continuous data to the emergency department through IoT. It will check for these 3 conditions. First, is it a normal range, 60 to 100 beats per minute? If yes, it will display normal BPM. If the beats per minute is lower or higher than the normal range, it will display with a specific condition. Okay, and the last one is measuring oxygen saturation. If the oxygen saturation is in the normal range, which is 66 to 100%, it will display level of oxygen saturation is lower than the normal range. It will display poor oxygenation. It will continuously monitor by the device and until they arrive at emergency department.
student studies sustainability development goal alignment. So the first one is good health and well-being. So they follow us to enhance the quality of patient care through continuous monitoring and real-time knowledge, eventually improving health outcome. The second one is industry innovation and infrastructure. To promote innovation in the healthcare industry by utilizing advanced sensor system and quality technologies. And for the last one is sustainable city and communities to help reduce the burden on healthcare facility. To reduce the burden on healthcare facility, our system is for active health monitoring and prevention. By continuously monitoring student health, the system can detect early warning sign of illness or stress. So, the point is to reduce emergency room visit. So the ER always overcrowded with many visits resulting from conditions that could be managed outside the emergency setting. Next.
So in conclusion, using IoT technology, we have developed a portable, reasonably priced patient monitoring system. It directly captures vital information from the patient such as heart rate, SpO2, blood pressure and also our pupil size and condition in order to enable our professional to view data remotely. We intend to develop a functional prototype with easy and intuitive design. The system efficiently captures this data and sends it wirelessly to the emergency medical provider. And also, our design enables systematic student monitoring, achieving our goals. Based on our objective earlier, this is all of this, if possible, completed. For the benefit of researchers and medical professionals, the gathered data is kept in a database prepared for in-depth examination and integration. Yes,
Okay, thank you. Good effort, very detailed explanation. I'm satisfied with your slide and your explanation. Tapi kita tetap bagi lagi lah. Okay, kita balik.
Thank you very much, Firdaus. I have a few questions regarding your project. Basically, your project is very good to me because we have, before this, maybe you have done some research on this. Before you start your capstone. Do you do any research on your project before you started your capstone?
A little bit because firstly, as my current recommender, we have emergency treatment lecture like that. But because actually a few times I have witnessed students falling down, accident. At one case, he fall into the rice bag, the cafe placed the rice, and his face torn off. Blood is all over the floor. But the UK only go hospital.
So it's good monitoring systems for this matter. Okay, so I have a few questions. The first one is regarding your component. We look at your component. Will you go back to your component slide? Okay. You have 4 types of component as your input. So if we look at one, which is the heart rate. Is that the heart rate contains right? So you are using the max 3010.
Yes.
So for this type of sensor, how can the sensor be integrated with ESP32? So you know, to measure heart rate. So do you know what are the requirements, additional info in order for you to connect with your ESP.
Okay, so many of these from scratch sensors such as Max 3002 actually need amplifier because the signal sent from these sensors is very small and they especially do have a bigger range than sensor. So you must actually need an amplifier circuit to connect it. And the port inside the sensor has all of the specification to be connected by a jumper wire or what? Dupont wire into the HPT2. But as I said, we need an amplifier circuit. And how it calculate heart rate is by if the blood volume came into a certain threshold, it will send an electric pulse. So it one pulse. So in order to limit the inaccuracy, we actually need amplifier circuits because the electric signal sent so small.
The Max 30102 send electrical signal to your ESP32.
Yes.
So you need an interface device between Max 30102 with your ESP32. So may I know the connection? How many connection you need for ESP? I mean between ESP32 and also Max 301. For example, for ESP32 you need 3 connection. The first one is VCC, the second is your ground, and the third is your data. So if we look at Max 30102, we have 1, 2, 3, 4, and 5 connected. So which connection that you use for your ESP32? If we look at the figure here, we have like 1, 2, 3, 4, 5, 6, 7, 8. So which connection that you have to use for your ESP32? Because there is no indicator there. So I think it's better if you study that connection, because when you buy it, you need to know the specifications. For example, if the sensor send data to your ESP32, the signal must be 3.3 volt. It cannot be 5 volt. So you need to make sure that the signal must be in that particular range. So please check that. That is the first question. The second question is regarding your microcontroller. Are you using ESP32 or you want to use Azmin? I don't know which one is the best. Which one? I mean, the best or suited with your projects. Which one is the best? What do you think? You prefer ESP32, so means that because you want to send your data to the cloud, so in order for doing that, you need something that can easily send the data to the cloud. So you use ESP32. So I have no other question, but that is my concern. You have to understand the behavior of your sensor. Because some sensor, it will not give the specific requirement for ESP32. Sometimes it has different signal. I also have problem with that. Actually, that's why I know, because my sensor, it sends 5 volt signal, so it is not compatible with why you need some interface, for example like ADC, so you can control the signal, and that signal is actually the same as the sensor signal that you send. Okay? That is all.
Are you sure that your microcontroller can operate with your MX301
Sensor heart rate
sensor?
sensor.
Can ESP32 integrate and analyze? Because you take the data, right? You take a pulse rate from the sensor, and then the sensor sends the signal to the microcontroller. So can this microcontroller integrate with your sensor? That's the question. So itu isu dia. Itu isu paling besar. You pakai barang canggih pun, tapi you punya microcontroller tak boleh. Dia mesti ada limitation.
I have another sensor actually. You mentioned about your blood pressure sensor, because in your slide you showed me the Omron blood pressure module. So when I googled it, I saw that this Omron blood pressure sensor module, yes, it can connect to microcontroller, but it doesn't mention what type of microcontroller. That's what I suggest. Have you did any research on what type of microcontroller that you want to use in your project? For example, you have Arduino, ESP32, and all that. Because in the internet, it doesn't mention about the type of microcontroller. But there is another sensor that can be used with your ESP32. For example, you can use EF robot blood pressure sensor. EF robot blood pressure sensor. So if you look at this sensor, it is compatible, like Sir Saiful say, it can integrate with your ESP32. So you look back at what type of sensor that you want to use and whether it's compatible or not, you have to check first.
Bear in mind, this is only one semester program. Itu kena tahu. Tadi you cakap yang BP monitoring tu you nak develop juga. Tak perlu. Don't waste your time. Kita bukannya nak soft, nak selamatkan dunia, tak. Understand? This Capstone just one semester punya program. Nanti you nak buat tu, you nak buat ni, at the end satu input pun tak boleh detail. Sebab you kena ingat, you ada oscillator, pulse rate, lepas tu you nak buat blood pressure. Jadi apa lagi tadi? Pupils, banyak. So nanti BP you nak buat, you nak develop sendiri. Nak buat apa? Sedangkan sensor tu dah ada jual. Just ambil, explore, and then boleh suit dengan you punya microcontroller. Tak payah ESP32. Nanti you buat sendiri apa semua, projek tak function, and then makan you pun lagi. Understand tak? Tengok objektif you nak buat apa. Tak perlu nak buat keren-keren sangat. This is just a Capstone, a small project, tapi janganlah buat projek yang terlalu simple dan janganlah terlalu complicated. Kena faham, this is week 6. Minggu depan dah week 7, semester break. Komponen dah beli belum? Dah start explore ke belum? Coding lagi? Saya bagi tahu, at the end yang problem nanti bila tak dapat, mula berlupa masa present tu tak jadi, kita tak nak macam tu. So, contoh macam tadi kan, patah balik yang oscillator tu tadi, yang FX30102, make sure boleh function tak boleh function benda ni. Kalau tak boleh, pakai yang sesuai ni cakap, just guna sensor tu integrate dengan ESP32. Function tak? Okay, ESP32 boleh baca. Okay, done for your first input. Second input apa? Bukan second input apa? Blood pressure tak payah perlu nak beli, nak buat online ni apa semua. Cari je yang second option ni tadi ni yang boleh, yang available dekat market, yang boleh confirm integrate dengan yang punya ESP32. Done. Okay, lagi apa lagi? Pupil. Kan, 3 benda kan? Pupil kena buat manually, betul? Kena buat manually by doctor. Okay, manually by doctor, okay, tak apa. Nanti dia keepingkan dekat kita. Okay. My suggestion, Nanti you kan flowchart you nampak complicated kan, banyak dia akan tengok, mula dia akan based on you punya oximeter, lepas tu BP, lepas tu BPS. Why not tiga-tiga data tu you combine, tiga-tiga data you combine. Pernah dengar nama fuzzy logic?
Fuzzy logic.
Pernah dengar nama fuzzy logic? Okay, you combine the data, you masukkan. Okay, kalau BP you tadi you ada limitation kan, kalau you punya oximeter nanti 6 tu dia ada rules, fuzzy ni dia ada rules, tapi complicated lah. Tapi kalau you boleh masuk all the data dalam fuzzy, nanti fuzzy tu dia adalah okay, condition nombor 1, katalah nombor 1, contoh nombor 1 you adalah you punya oximeter kan, you punya oximeter kadar oksigen dalam jantung you, katalah dia 96/100, which is good. Okay, condition nombor 1 good. Tapi condition nombor 2 you katalah nombor 2 you adalah heart rate, tapi heart rate you rendah, heart rate you tidak bagus, tapi pupils you good. So dia duduk dalam kategori mana? You buat 4 kategori, you faham tak? Kategori pertama good, kategori kedua mungkin biasa, not critical, kategori ketiga critical, kategori keempat severe. Jadi tak payahlah lagi doktor tu nak letak dia apa semua, dia letak. Okay, dia tahu you ada satu database, yang mana database tu dia smart untuk you. Itu cadangan saya lah. You ada satu database, okay, you ada 3 input, oximeter, and then you ada input heart rate, dan you ada input pupils. Setiap input ni 1, 2, 3, setiap input ni 1, 2, 3, setiap input ni 1, 2, 3. Bila 1 paling bagus, 2 tidak bagus, 3 ni sangat tidak bagus lah. Kalau dia 3, 3, 3, yes, itu fuzzy. Maksudnya nampak tak smart, tak perlulah orang tu lagi nak ingin benda tu. You ada satu database, dia sendiri yang boleh bagi jawapan dekat itu. Faham tak? Itu nama fuzzy. Dia yang select untuk kita. Contoh fuzzy ni apa? Contoh macam mesin basuh kan, dia ada mesin basuh, fuzzy logic. Apa dia buat mesin basuh tu? Dia tahu you masuk air kan, dia masuk air, dia kira berat kain tu berapa, terus dia tahu okay, air kena masuk berapa minit, ni kena masuk berapa minit. Dia just input daripada berat kain tu berapa, tu fuzzy, dia desainkan untuk you. So tak perlu lagi, maksudnya kerja-kerja apa nama ni, yang MA, medical assistant kat sini, dia tak perlu decide pun, dia just cuma check saja. Dia check betul apa, hari berapa dia dia masuk data apa, dia masuk dalam you punya database, terus dia decide student ni condition dia severe, nombor 4. Nampaklah dia smart dekat situ. Berdasarkan, tak perlu fikir pun. Yelah, maksudnya sensor tu memang dia perlu fikir. You punya smart dekat dia punya data analysis. Pada saya lah, data analysis tu masuk data okay, ni tadi ada 3 input kan, 1, 2, 3, 1, 2, 3. Kalau kita nak 3, 3, 3, okay, budak ni critical ni, budak ni critical. Terus sistem tu yang bagi tahu ni kena letak red zone, ni kena letak red zone. Dia data tu MA yang masuk, yang decide ni adalah AI, fuzzy. Kalau you boleh buat macam tu, jadi tak perlu sebenarnya fikir nak buat sensor ni, nak buat sensor. Just use apa yang ada dekat market, tapi you develop the system. Tapi itu next. Kalau pakai fuzzy, dia tak perlu fuzzy, tak apa, dia pakai Excel dulu. Tapi nak canggih pakai fuzzy lah. Dia tak masukkan data dalam Excel, data tu. Tapi kalau fuzzy ni belajar mungkinlah complicated sikit, tapi benda tu senang je sebenarnya. Kalau dia boleh buat, dia ada set of rules, triangle macam tu. Kalau dia jatuh di area, dia jadi dekat mana, condition apa. Nampak tak? Dia jadi, itu baru dia buat. Kata balik tajuk dia, kata tajuk student health monitoring system. You barulah dia boleh buat smart student health monitoring system. Smart dia dekat mana? Manusia cuba kita data, the rules, the decision used by AI. sesuai dengan tak smart. Saya suka dengan you punya presentation. It's very detailed. Tapi tak perlu sampai nak develop sensor, bukan kerja ni nak buat develop sensor. Ambil pakai, tapi you fokus on data analysis. Smart ni dekat mana? Okey, bukan kerja MA untuk MA tak decide pun. MA just check mata apa semua. Dia tak perlu pun decide orang red zone ke apa. Dia masuk dia dah kata automatically result dia keluar. Red zone. Nanti dia akan ada buzzer kan atau pelampu LED tu kan. Merah. Tapi macam mana nak integrate that data dengan ESP itu? Boleh tak? Saya tak tahu, saya hardware memang hardware untuk ni saya pun tak. Jangan orang di sana.
Ini you kena fikirkan dari segi calibration your sensors. When you want to use the sensor, you must calibrate. For example, you have another type of device that is used by the clinic, and then you use your sensor. You have to whether this device and your sensor are parallel. So, kalau bacaan dia ini dapatkan tiga yang what used by medical system. This one dapat satu ke dapat kosong ke?
Dia tak sama juga.
It's not calibrated well. So you have to do some calibration before you.
Inilah nama dia develop a system. You buat satu sistem untuk mudahkan orang. Sebelum ni kan doktor kan dia tengok je ni tak kita sangat ni boleh jalan ni sebab pada dia tak kita. Kalau sistem yang buat dia nak review tak? Dia tak boleh review sebab ni di sistem yang design. Dia dah buat sistem tu very detail. Dia dah buat database ni sangat detail. Itu pandangan saya lah. So you delete kan apa nama ni. Tak perlu fokus on your apa sangat, tapi sebenarnya fokus on your data, analisis data ni lah yang orang buat biomedik ni benda ni lah. Sistem ni disatkan betul. Tak payah, ialah kerja doktor tu jadi lagi mudah. Doktor tengok ni, tapi sistem kita ajar dia, kita train dia supaya sistem tu betul pandai. Boleh dia kalau dia nak pakai neural network tu dah itu lagi complicated lah. Tapi pakai fuzzy yang tu. Sebab masa saya dulu kita ada fuzzy dengan Kak Syah kan, dengan Prof Syah kita buat fuzzy kan. Kalau orang ni tanda ni dia demam ni. Kalau dia bukan demam lah, fuzzy. Explore fuzzy boleh tak dia dengan sini? You boleh tukar tajuk ni IoT, fuzzy blah using fuzzy logic, Mohd monitoring system. Confirm saya dah kita. Tapi ini pun payah sebenarnya. Payah. Itu sebab saya tak nak fokus on the sensor. Saya tak nak fokus on sensor. Tak perlu nak buat sensor.
Maksud bisa Saiful tak fokus je, bukan maksudnya
abaikan. Tak perlu develop sensor. You tahu nak buat sensor tu orang budak master buat PhD yang develop sensor. Dia tak nak sensor kita pakai yang boleh pakai dia untuk macam tadi lah, macam saya beritahu untuk blood pressure pakai dia. Sensor yang boleh kosong kan dia tak boleh buat, dia kena check. Buat degree je, kalau dia buat master tak boleh. Sensor saya nak buat sensor tu orang PhD dia nak buat sensor, nak buat apa tu tak boleh. Tapi orang tak boleh buat sensor kan. Dia pakai je. Yang macam tadi dia nak buat DP tu kan, machine tu tak pernah. Ini bukan maksudnya saya tak macam orang tu dia dah 100 lebih kan. Mana 100 lebih, lepas tu nak buang macam tu je. Okey, lagi pakai je. Dah beli dulu.
Tapi dia compatible tak dengan ESP tu? Yang SPS tu yang Umrah
tu compatible ke?
Yang tadi tu gambar tadi.
Lepas tu you kata tadi nak buat motor bola nampak tu kejut saya.
Lalu motor tu ada dah.
Tak payah. Don't waste your time.
Saya pun dah banyak apply dah.
Kita apply.
Saya dah apply, lepas tu output tu saya analyze. Lepas tu saya dapatkan bentuk model lah. Bila saya analyze tu, saya develop model tu saya pakai.
Yang penting kena tahu sensor tu output dia operate pada berapa volt. ESP tadi tu kata dah 3 volt. Sedangkan you punya sensor 5 volt. Macam mana dia nak kenal signal tu? Ni kenal 3, ni kenal 5. Macam mana nak buat? Itulah you kena ada analog ADC, analog to digital converter. Baru dia match 3, ini pun 3. Tapi macam mana dia membuat 5 ni kepada ni? Kalau 4, berapa? Very story itu saya very story. Okay, communication ni. So conclusionnya saya suka ini punya presentation, very detail, dia dah buat research, sangat bagus. Saya nak tengok penghasilan dia nantilah. Research yang dia buat very detail, bukanlah nak compare dengan guru tadi. It's very detail, dia dah nampak lah. Dia nampak apa yang nak buat. Tapi you kena make sure, ini betul ke, boleh ke dia punya
Jadi punya tajuk pun dengan objektif dengan
yes, problem statement very clear. You punya objektif sangat betul. First to develop bla bla bla. Second to buat. Lepas tu to evaluate. Betul tak? Dan dulu buat ni, okay,
tajuk pun okey.
tajuk pun okay, right. Saya suka. So saya tunggu nanti CV macam mana. Hopefully sukses lah. Tapi jangan terlalu sebab you ada FYP lagi. Okay. Nanti esok FYP dulu ada. Ini itu pun sama penting. Okay, alright. So I think that's all. Thank you very much. Kami juga presentation ni, tapi saya puas hati lah. I'm very satisfied. Okay, thank you.